Okay, looks like I am starting. I was reading this and then I crashed. But it looks like it'd be minimum ASCII sum, minimum ASCII delete sum for two strings. Given two strings, return the lowest ASCII sum delete characters to make two strings equal. If you have C and EAT, you're going to delete the S or the T and keep the EA. And then the sum is going to be S plus T with delete characters, which is going to be 115 plus 116, which is 231. And then for the second example, delete versus leet. There's two possibilities. You can either keep the EET or the LET, and it makes more sense to keep the LET because the deletion characters have lower values. So DEE here and E here adds up to 403. Strings are 1000 in length. I feel like this is probably dynamic programming. A lot of times trying to compare two strings to somehow find like the shortest ways of making it equal. It's very much aligned with dynamic programming. Classical cases for dynamic programming. So I think maybe I'm going to visualize this as rows and columns for the indices of the two strings. And then my matrix based on those rows and column dimensions is going to give me the lowest value deletions that work. Something like that. So for every index in S1 and every index in S2, you can if they're the same, then you can keep them. If they're different, then you can skip the index from S1 or skip the index from S2. Okay, so I think yesterday or the day before I had dynamic programming. But here, dynamic programming, the rows and columns for this is going to be the length of S1 and the length of S2. And my dynamic programming matrix is going to be, say, I guess it's probably going to be positive infinity. It needs to be really high value thing that you're lowering. I guess maybe, actually I recently did dynamic programming one that just used an array, right? So maybe I just need a single array, dynamic programming array. It should be, so how am I going to visualize this? SEA is probably going to be the rows, EAT is the columns. So like this is index 0, 1, 2. This calls. So if I iterate over, so I think I need to have the array equal to, have the rate equal, I don't feel like this is, I think I prefer going the other way around. So like EAT and SEA, and this is the number of rows. And then iterate over the number of columns per row. So let's say equals, I think it's something like infinity times the number of columns plus 1. And rows. I think it was the maximum dot product of two subsequences. Okay, yeah. This is 2 days ago. as I remember, it was a lot of painstaking error corrections or bug fixes. That okay. Let's try to do this in completely less than that. So SEA. So I'm going to iterate over God, this looks horrible. EA EAT. So I'm going to iterate over the rows first, the outside loop. There are your C and range columns. So for each index, so if the index is 0, 0, if the index is 0, 0, play, yeah, oops, I think I need dp of 0 to be equal to 0. And I think I need a next row. Right, did I? Yeah, I had a current row and next row. Okay, current row, next row. Oops, this is going to be current row 0 equals 0, and current row and next row is also infinity. So infinity represents the fact that we're assuming by default takes an infinite number of deletions or valued deletions to arrive at that spot in the state, in the space of indices. Okay, so I can just immediately go to what happens at row and column. So like if I am at 0, 0, this only works to keep if they're both the same value. So let's say I take the letters from H. So let's say letter 1 is equal to S1 at this index. Letter 2 is equal to S2 at the other index. So I can keep both if they're the same. So if letter 1 is equal to letter 2, which is ideal. Actually, I think I might need to do the skip case first. Do I? No, I'll just do this case. So if they're both the same, then I don't need to delete them. Would be, I could still delete them, but I don't need to. Is it ever better to keep them if they're the same? Can't think of a case where you would want to keep two letters that are identical, like if S1 started with S and S2 started with S. Can't see why you would ever want to maybe skip not deleting, or rather than assume that they are matching and they're going to be part of the ending strings that are equal, that you delete one and keep the other. So I think if they're the same, then you definitely just want to skip. Okay, so skip deleting them. So So if I skip deleting them, then I should, whatever the current value, whatever the current sum of deletions, which is going to be the current row at this index, whatever that current row at this index, that should be pushed forward to be next row at the index plus 1, at the column index plus 1. I don't see how, I don't think I need to do a comparison there. I think it's just gonna, it should always be assigned there rather than do some sort of min calculation there. Okay. I think I can do continue here. I guess letter 1 is fixed within when R is defined, so here I'll say let 1 is equal to S1 at R. It's only letter 2 that changes within the inner for loop. Okay, so if letter 1 and letter 2 are not the same at this point, then I can either skip deleting, I can delete S1 or delete the letter 1 and move on to the next character there, or I can delete letter 2. So I think here there should be something like the current sum is smaller than whatever is in the next row at the same column. The next row at the same column is equal to current sum. And then if current sum is less than next or current row at the next column, current row at the next column is equal to this current sum. I could also do like I could do next row is equal to the min of 2 things, but it's actually maybe slightly slower because if you do the min thing, it's always forces you to do assignment. It does the conditional, and then it always does the assignment. Whereas this does the conditional and sometimes does the assignment. Anyways, I think that might be it. And then after the loop it needs to switch next row and this row. So now current row and next row get swapped. Oh, it does one other thing. It needs to push the last column. Next row. Save that estimate. So this should probably be an if. This should always be. This should be a if statement. If next row at the last column, which is calls, is bigger than, if bigger than the current row it calls, then next row it calls is equal to current row it calls. And then you do the swap of rows. Okay, and then answer should be the minimum of either the min of the last row, right? Min of the current row. Or the last number in the next row. And then does there need to be any special things after that? I think that might be it. Okay, 0, 0, 0. I wonder. Yeah, I guess it pushes the 0 a bunch of times, doesn't it? Oh, I'm not even doing it correctly. This is horrible. I can't just, when I do the skip of this row not matching, or this index at the row, the letter at this row versus the letter at this column, if it doesn't match, then it's actually pushed to deletion. So the current sum needs to be increased by whatever I'm skipping. So if I'm going from the current row to the next row, I'm skipping the character at this row index. So it should be the ordinal value. Offset is the ordinal of value A. I think it's all lowercase, right? Okay. Ordinal of this character. Letter at this row, which is letter 1 minus the offset. Actually, it's just ordinal of that. Yeah, it's just converting it to integer. It's not like A is 0, B is 1. It's just like A is 112 or something like that. And then if I skip this column, going to the next column, then I need to increase by the value of the column, which is letter 2. Okay. Literal S. Yeah, I thought maybe. So letter 1 is a string. I thought I could just convert it from. I thought it was a character. From base 10, say. To do some sort of convert it to a. Oh, yeah, I should be using ordinal. I should be using ordinal. What's going on here? Somehow odd. Somehow use a shortcut to change the questions. Okay, so yeah, this should have been ordinal, I guess. Huh. Some faulty logic in my head here. Okay, well, it gave me something. Not good. Current row is 0 equals 0. For every row index R, column index C. Current sum is current row at C. Letter 2 is S2 at C. If they match, the next row at C plus, oh my god, what am I doing? Next row at C plus 1 equals current sum. Wow. That's pretty bad. Okay. Okay, there's more errors. I think that's right though. If current sum is less than current row at C, or next row at C, then you're going to skip the current row letter, which is ordinal letter 1. Let's see. Okay. My god. Here, this should be next rows at columns. I think this is probably skipping. Yeah, this is skipping it, right? Skipping the ending row. So if next row at columns is greater than current rows, that's ordinal of letter 1. Should probably keep this consistent in terms of comparison order. This is smaller than next row at calls. I wonder if I should just be using ordinals. Okay, well, let's see if this works first. Missing a semicolon. Do 97 still 0 still. Letter 1 S1 at R. Letter 2 S2 at C. The letters match. Push. Okay, let's do a trivial test case, one that doesn't require any sort of deletion, and see if it works. If this doesn't work, I'm going to be very sad. Okay, it works. So next row is equal to current sum. I think that's right. Okay, let me go ahead and just double check the last thing. Actually, definitely within the arrays. S-E-A-E-A-T. So should do S. Should do S compared with E. Skip. Delete the E. S compared with A. Skip, delete the A. S compared with T. Skip, delete the T. Alternatively, and then, yeah, that's fine. And then the next sign does E compared with E, keeps them. I think I need to just have one final point out here. After the inner for loop, just print out what is current and next. Okay, that looks correct. It deletes the S, deletes the E, the A, and the T. And then 115 is if it deletes the S. 216 if it deletes the E and the S. 313 is if it deletes the EA and the S. And this is if it deletes the EAT and the S. Yeah, so here's 115. So this means that's comparing the E with the E. So it should be saying that it's fine. Yeah, so 115 here pushes the 115 to this spot here. Because its E is equal to E, so it should be able to skip deleting anything there. And then similarly, how is it getting 1 of 1 here? 1 on 1? Where'd it get that? 115, pushed 115 here. 216. Yeah, I think this is correct here. It should probably be, I'm guessing it should be something like if letter 1 equals letter 2, then here it should be that continue else next row at C plus 1 equals infinity. Because it needs to clear out that spot logically. Yeah, it needs to clear out that spot, and then it needs to not do an if statement here. If it does a skip, then it just does a skip. Is that right? No. It does comparison here because it can be infinity at this point. So what happens to the first index? If you have index 0, then it's never going to have infinity. Maybe I need to have a next row at 0 equals infinity. Do that all times. Comparison. Okay, I think maybe not quite. 231. Next row 0 should be infinity. But then you have infinity to start with. that's not right. That's not right. The next row at 0 should just start with. Should it start with something? Should it start with the current? Should it start with something like the current row at 0 plus deleting so you're here, 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 and here. So like this is okay. So go 0, 1, 2. 0 should be able to affect 5. 0 should affect 4. If you delete S, you would add S to whatever sum is at 0 and get 4. If you delete S, then you get the sum of whatever's S to get 5. The 5 could already be smaller than whatever this. 5 could already be smaller. So you can't just force it, I don't think. So close. Delete. Delete here. Push it to here. That has to be the best. Otherwise you say it's infinity there. If you delete here, then we should next row delete here. Next row at 0 equals current row 0 plus ordinal of letter 1. I think that's always true. And then this thing compares to this thing. I think this is the same mistake, right? Yeah. Somehow I'm still getting infinity here. On. I'm still getting infinity. So I should delete the S and the T. So it should be something where I go from 0, 115, 115 goes to this thing, 115. This thing goes 115 to here. And then that 115 should delete the T and get to this should be 231 right here. That should be 231. So then this 115 here should be 231. Let's see. Well, it should be the minimum. No. I need to actually do the last row. I need to iterate over the last row. order over the last row. I don't know why there's infinity here though. That should have changed from 115 to 16, made this infinity. To 16 made that infinity. And then this thing, okay, let's see. So this should have been something where this thing is automatically done. Or this is always done still. Yeah. I need to do one last pass in the last row. Yeah, so this is not right. The logic of the last problem is just not comparable to this logic here. I just can't do the minimum of the last row. So for every column in range calls, just for the last row, and you do something like if current row at this column, the current row is currently the last row, plus ordinal whatever letters here, S2 is less than current row at the column plus 1. Then current row at column plus 1 is equal to current row at all plus ordinal plus 2 at C. And I think that might fix it. I think at that point I can actually I can just do the minimum. I think I can actually just do current row at -1. The last value of that current row. Oh. Right. Let's see if this works. Holy shit. I don't think this was any easier than the one that was 2 days ago that was hard. Same fucking dynamic programming stuff. Alright, I am gonna forgo this sort of speed and just make this more condensed. I think this should just be next row at column is equal to the minimum of next row at column versus current sum plus the ordinal of letter 1. And then current row at column plus 1 equals the minimum of current row at column plus 1 and current sum plus ordinal letter 2. Guess I don't need an if else. I don't need this continuous as this last thing within this for loop. Looks like I can just do an compacted tertiary operator here. If else. next row at c plus 1 is equal to current sum if letter 1 equals letter 2, else it equals infinity. Alright, this one's going to be next row at calls equals the minimum. Next row at calls versus current row at calls plus ordinal letter 1. Swap the rows, and here this should just be current row at c plus 1, min current row at c plus 1, current row at c plus ordinal of s2 at c. This should just be return the current row at -1. Alright, there's one other thing I want to fix or compactify. I think I just need to find the ordinal of the letters. So I think I'll say letter 1 is just the ordinal S1R. And next row is equal to current row plus letter 1. Current sum is equal to that. Letter 2 is the ordinal of S2 at C. And then I can just change all these to letter 2 and letter 1s. Ordinals can be compared now. Letter 1, letter 2. Oh, this is outside the scope of this thing, so it's fine. Okay. Okay, this probably is going to be a little slower, but code looks a lot better, and just more simplified. And it's slower because of the minimum change from if statements to min. These min statements are going to be slower because they have a forced assignment or a guaranteed assignment, whereas the if statement version would have sometimes a skip of the assignment. Still the same comparison. Okay. Everything else looks fine. Okay. So for summary here, this is going to be very similar dynamic programming problem and technique used as the one on 1.8 26 2 days ago, which was the smallest. What was it? Wasn't this? Max 1.458. Max dot product. So I used a comparison of the solution there to do a lot of the mental structure or mental lifting and Leetcode structure. So for this dynamic programming, basically, for dynamic programming in general, define or consider states and values of states. It should be state inputs. So here the state inputs would be the row and column indices of S1 of the string 1 and string 2 respectively. And the value of state, or the output, would be the smallest sum deletion value, or deletion sum value up to those indices. So at a particular state, or R and C, you have three options, kind of. If you have the S1 at R is equal to S2 at C, so they have the same letter, like S equals S, or T equals T, or E equals E at those indices, then push the current sum to kind of S1 to R plus 1, C plus 1. Because basically you can skip deleting the letters, the equivalent letters at those indices. You can delete the letter at R, which is in the first string. So just push current sum plus the ordinal of the letter at R to R plus 1 C, and then delete the letter at C, which means you push the current sum plus the ordinal of the letter at C to R C plus 1. Make sure not to push a higher sum than what can be achieved in another path to those later states, rows and columns. So if you are seeing if you can push deletion, this value that you would get for pushing that deletion needs to be smaller than what could be also achieved through other means. So don't kind of push without checking that. It's going to push a smaller sum deletion value. And then make sure to handle the edge kind of rows, columns correctly, which I definitely did not do on the first or second or third go. Especially the last row. And then return the kind of final entry in the matrix, which should be the smallest sum deletion value. Alright, so yeah, so it starts with infinity for the current row and next row, which represents that you start with a high value and you try and get the low value, the lowest deletion value. You're saying it's arbitrarily large currently. That being the case, the first value when you enter in the matrix, it is going to start with a zero sum deletion. So current row 0, which is index 0 for R, and column index 0. And then iterating over your row indices, you're going to look at the letter at that row, which is indexing within string 1. This is just next row at 0 equals current row 0 plus letter 1 means if you were to delete or skip, I guess delete is the better way of thinking about it. If you were to delete the letter 1 from consideration, so that would be if SEA was string 1 and EAT was string 2, then you're deleting S from string 1, and you're considering that would push onto the next iteration where you have E as the row from string 1. It would be now 0 plus whatever the cost of deleting S was. Anyways, so now iterating over the columns of C, again, for the outer loop of R being equal to 0 or the letter being equal to S. So as compared to EAT of string 2, current sum is going to be 0, C0, letter is going to be E. Next row at C equals, so this is just deleting the current row. Oh, I wonder if I actually need this here. I think I do, but I can't recall why, because this does. Oh yeah, I know why. I need this because I don't use a matrix. I use two alternating arrays. And the alternating arrays might have some dirty values. So this thing needs to be pushed here. Yeah, so anyways, this is deleting the current row and pushing onto row plus 1, C. This is deleting the current column, pushing to C plus R, C plus 1. And this is deleting both, or deleting nothing. So keeping R and C if they're the same, or if they're same, then keeping them the same. So current sum doesn't need to increase if the letter 1 and letter 2 are the same. But if they're not the same, then pushing infinity. And this infinity is pushed is because, again, I'm perhaps complicating things with using matrix. If this was a matrix with infinity, it would probably be a lot simpler, less dirty values. Anyways, alright, time complexity, this is going to be O of mn, where strings are length m and n respectively. As we need to iterate over every letter in string S1 compared to every letter in string S2. Doing a constant work for each comparison. So basically, this is O of n, or O of n, since using alternating arrays for current row and next row. I should say that would make it a lot simpler to have used a matrix, in which case its base would be O of mn in that case.